Welcome to LNP Renewable System Integrator. Today we are going to see some of the design basics of the solar PV system. Okay, so what are the steps? Okay, which are involved? What are the steps in designing a solar power plant? Okay, today we are going to see with the simple examples. Okay, so as we told earlier, these are the steps. First is the planning. Proper planning prevents poor performance. So planning is very much important. Second thing, we need to collect the information, whatever information that we require. Say for example, if you're going for a site, so you need to collect the data. Okay, how the transportation facilities are there, whether we have a storage locations to store the solar cells and the inverters. Okay, how difficult it is, how difficult the location is the accessibility issue is there or not, and how much wind speed is there, and how much temperature is there, do we have any shadows there. So like this, so many informations we need to collect. Then we need to do the load calculations. So we need to physically visit the location. We need to check how many electrical loads are there, how many AC loads are there, how many DC loads are there, how many inductive loads are there, how many capacitive loads are there, how many MV panels are there. So like this, we need to know, make an analysis of by collecting the information. We need to do the load calculation, and next we need to decide is how much sizing of solar array we can do. Okay, how much area is available, length and width details we should know, how much area is available, so that we can provide the solar power. Maybe sometime in certain locations, we will have a big spaces, but the load will be very less, so we can put the solar panels for the entire area. In certain locations they will have a at the rooftop they will have a big load, but the area will be very less to put the solar panels. For that we need to see the separate locations to provide the solar array sizing. So for that one, site visit is very much important. Collecting of information and the data is very much important. And certain places, if they are asking battery supports, off grid supports, then we need to decide the battery capacity. Okay, in certain places, we can put inverters everywhere. In certain places, charge control is sufficient to handle the some sort of things, means then we need to select the charge controller. And in certain places, if you need a inverter okay, then we need to decide the inverter capacity. Okay, and most importantly, we need to know the structures. Okay, how much structure is essential to mount these panels, and also we need to know about the wirings also. So as we told earlier, proper planning prevents the poor performance. Okay, so if you're going for a collection of information, you need to know the load and the application, whether it is AC or a DC, and what is its operating voltage, and how much is the daily consumption. Okay, and what are the criticality of the load. Okay, and what is its monthly and weekly load profile. All these things we need to collect. And in case of climatic conditions, we need to know the latitude, longitude. Okay, tilt angle, temperature, so many things that we need to know. Okay, and also user compatibility also is there. We need to understand the technical issues. Okay, and how far the maintenance required in such places, that also we need to analyze. And if you're going for a factories, there is a possibility for so many pollutions. Okay, that's to accumulate on solar panels. Such things also we need to consider. And if you're going for a floating solar, there is a possibility for the debris of the birds waste, okay, to accompany our solar panels. So we need to prevent that. So we need to know how much maintenance schedule is essential. Okay, and we need to check the budget constraints. Okay, whether and also energy budget. We need to understand and manage energy budget. All these things, in order to do, we need to collect so many informations. So, and if you're going for a load calculation, we have a basic formula to calculate the load calculation for a DC load and a AC load separately. If you're going for a DC load, you need to know the amps rating of the load into, you need to multiply it with the operating hours per day, how many hours it is going to operate. Okay, so this is how you need to take the amp hour per day for a DC load. And if you're going for an AC load, AC watts, okay, AC loads wattage into the operating hours per day. Okay, and if you want to calculate ampere hour per day, okay, this is the watt hour per day. If you want to do the ampere hour per day for this AC load, what we have to do, the watt hour per day that we got now, divide that by the inverter efficiency and the nominal system voltage, you will get the AC load. Okay, and if you're going for a sizing the solar arrays, okay, how many number of solar panel that we want to do connect in series, how many number of parallel connection that we want to make, then we need to do the calculation. That is, we need to know the nominal DC system voltage. Okay, if you divide that by the nominal voltage of the solar module, then we will get the number of series modules. Okay, and if you want to do a parallel connection, then we need to know the amps hour per day divided by, okay, we need to know the module derating factor, and we need to know the battery AH efficiency and Imax, and we need to know the solar installation of the first month. Okay, and also we need to know number of modules that we are going to do form a solar array. Okay, so for that one we need to multiply this number of series panels and the number of parallel module panels. Okay, and if you want to know the capacity of the entire solar array, then we need to do the what we need to do, we need to know number of panels, so that we already calculated, and we need to multiply it with the capacity of the each modules. Okay, in most of the cases for the derating factor we can calculate as a 10%, because there is a possibility for dust, mismatch, orientation, so many factors are there. Okay, and if you're going for deciding a battery capacity, okay, how much batteries that we want to do, what sort of capacity is required, and if you're going for that, basic things first you should know. That is, if you're going for a residential load, okay, number of backup days can be from 3 to 5 days. If you're going for industrial loads, they will ask for high capacity battery capacity. It might be from 7 to 14 days. And if you go installing in a place where the poor weather conditions are there, then there you can go for 17 to 14 days. 7 to 14 days. Okay, and most important thing that you need to know in a battery is that depth of discharge. Okay, for normally 80% will be for the deep cycling, and 15% of will be for shallow cycling. So this is the depth of discharge that we should know. And also, you need to check the temperature variations of the site. What is the temperature? Because based on the temperature variation also the depth of discharge will vary. So that one you can check the data sheet of the battery. That one battery manufacturer has clearly mentioned what will be the maximum depth of discharge at the different temperatures. All these things we need to analyze before deciding a battery capacity. Okay, and if you're calculating a battery capacity in AH, first thing that you need to know is amps hour per day and number of backup days. So number of backup days you can calculate with the help of this. How? If it's a residential load, so if it is a residential load, if it is a residential load, it will be from 3 to 5 days. You can go for 5 days and divided by the maximum depth of discharge, so that you can calculate the battery AH required in battery capacity that is required. Okay, and if you are going for a number of batteries in a series connection, then you need to know the system DC voltage divided by the battery voltage, so that you can calculate number of batteries in series. And if you're going for a parallel battery connection, then you need to know total AH required divided by AH of the individual batteries. And what are the salient features, okay, of the charge controllers that we use? The power device should be of a solid state. Okay, it should be have a protection against the surge or a transient. Okay, it should prevent the batteries through the solar panel during nights, and also you should have a protection against the overcharge of the batteries, and also you should have the reverse connection of the battery in the module protection. Okay, robust enclosure and cooling with the heat sinks. Okay, and most importantly, you should have a good features against the control temperature set points, equalizations, all these things we need to check. And also we need to have a suitable MCBs or the solar input, probably 100 amps. Okay, and if you're going to calculate the charge controller, maybe the number of parallel modules into the short circuit current into 1.25, so that you can calculate the charge controller capacity. Okay, whatever value you're getting, choose the highest one, value above that one. Okay, now if you're going for a structure, so how you can calculate this total number of structure? It is very simple. If you know the number of modules, then divide that number of modules by number of modules on a single unit of structure. If single structure has a capacity to hold two panels, then your number of panels will be the two. And say for example, if the number of modules, say for example, let us consider the number of modules is 100, and a single structure can hold two modules. 100 divided by 2, so it is obviously 50. 50 will be the number of structures. So like this, you can calculate the structure sizing. Sometimes in certain places, single structure can withhold 4 modules. Then 100 divided by 4, so the number of structure required will be 25. Okay, so this is how you can make a structure calculations. Okay, now let's try to understand these basics with an example. So as we told earlier, if you're going to calculate the DC load, okay, we need to know number of DC devices and multiply that number of DC devices with the DC watts and how many hours you're going to use daily, so that you will get DC watts hour per day. Okay, similarly for all the other devices you calculate. Okay, and second, if you want to calculate the AC load and you want to convert that as a DC, it's very easy, simple. Number of AC devices into the device watt into hourly usage. Okay, so you will get the AC watt hour per day. And if you want to convert that AC load into a DC, simple, divide that value by 0.9, it will get converted into DC. So now you got the total DC loads which is required. So say for example, let us consider in the A we got a 2000 watt hour per day, and in the B we got 1500. So our total is 3500 watts per day. Our load demand is 3500 watts per day. Now if you want to determine the total DC amp, okay, hours per day, is very simple. Total system load divided by the system nominal voltage. So let us consider the system nominal voltage is 48 volt. Okay, and our total load is 3500. So divide this 3500 by 48, we will get the 73 amp hours per day. Okay, and if you want to determine the total amp hours per day with the batteries, very simple. Total amp hours per day that we already got is 73. Okay, so consider the battery has efficiency of 49. So if you refer the data sheet, you can get, and if you have a module derating factor, it is 0.9. So we will get around 90. So if it is a 90, you can go for a 100 amps hour per day. Okay, and if you want to determine the total PV currents, what you can do, total daily amp hour requirements divided by the design installations. Say for example, as we already calculated the total amp hour per day of the batteries, that is 100 divided by, let us consider 5 peak solar hours, means divided by 100 is 20 amps will be the total PV array current. Okay, and if you want to select the PV module type, okay, all these things you should know. What is its maximum power, what is its maximum current, what is its maximum voltage, all these. For example, here they have given an example of 75 watts. Okay, so here 75 watts. Okay, and next step is that if you want to determine the number of modules in parallel connection, that is total PV array divided by modular operating current. Say for example, if our PV array current is say 20 amps, okay, and your module operating current is 4 amps, then approximately you have a 4.5, then you can go for a round of value, that is 5 number of modules that you need to connect in parallel. Okay, if you want to determine the number of modules that you connect in series, system nominal voltage divided by module nominal voltage, that is 48 volt divided by 12, that is 4 modules. And if you want to determine the total number of modules, you want to multiply the number of modules in parallel and the number of modules in series. 5 into 4, it is 20 module. Okay, so which is of 75 watts, so that you will get, that is approximately 1500 watts. And if you want to determine the minimum battery capacity, what you have to do is that total daily amp hour per day with the batteries that you got already in the step number 5. Okay, multiplied with the desired reserve time, that is number of days, divided by the usable battery capacity percentage. Say for example, if our total daily amp per day with battery is 73 amps, okay, multiply it with the 3 days divided by 0.8, we will get approximate value of 274. You can make it as around of 300 amp hours. And so based on that, now you can now you are pretty aware of the 300 amp hour battery capacity required. So you can choose a battery. Okay, you can have a 3 strings in parallel. Okay, in a parallel connection, if you so that if you're going for a 100 Ah battery, you can have a 3 strings in parallel, so that you will have a capacity output of 300 amp hour rated battery. Okay, and if you're going for a 150 Ah battery, then you can connect the 2 strings in parallel, so that you will get a 300 amp hours. Okay, and if you want to choose a charge controller, as we told earlier, number of parallel modules into short circuit current into 1.25. So since we already know that number of parallel modules that we calculated is 5. Okay, and short ISC is 5 amps, and 1.5, so the output is 31.25 amps. So round off, either you can go for 40 amps rated charge controller. And if you're going for a choose a inverter, you need to know that total AC watt of the AC device is into 23%. You will get a value that is the rated inverter that you want to choose. Thank you so much. Please subscribe and press the bell icon if you want to do projects with us. If you want to know more and learn more, okay, you can contact us. So we had provided the contact details in it. Okay, we are providing design, installation, testing and commissioning support for solar, on-grid, off-grid and hybrid applications. And we are also providing the training for the solar. If you want to have a basics, know the basics of this solar power plants, you can contact us. We are providing the trainings, and also we are providing the design, installation, testing and commissioning, training, consultancy supports for the automation industry. And if you want to do for industrial automation, home automation and the building automation, we are providing the supports. You can contact us. We had provided the contact details. And if you want to know the basics of this automation, building automation, okay, BMS system, building management system, you can contact us. We are providing the contact details in it. We will provide the trainings for the colleges and institutions. You can contact us. And also we are providing, if you want to know the basics of electrical vehicles, for that also we are providing the short-term trainings. You can contact us. We have provided the contact details in it. Thank you so much. And the session is not yet end. Since we discussed so many examples, how it will look, how where we can see those things also I'm going to explain. Be in line. Okay. See here, as we told earlier, so this is a data sheet of a PV module. I had given you an example. See here, this is a REC panel. Whatever a panel that you get, try to get this data sheet. In the data sheet, all the details are available. So as we told earlier, so we had taken from the IAC, from the IAC. We had in so many places we had used IAC, that is short circuit current. You will have a pretty doubt what it is, how it is utilized. So this is a short circuit current. If you are calculating, if you are using any module, whatever module that you are using, you can with the help of these data sheets, you can try to get the short circuit current ratings of this particular module. And if you want to know, okay, the nominal power also you can calculate. Okay, and if you want to know the MPP current, you can see this one. Okay, and if you want to know the open circuit voltage also, you can see that is 44.9 volt. Okay, this is an example like this. For a different modules, we have a different parameters. So with the help of this data sheets, you can try to get. And also, as we told, discussed so many things in the junction boxes. See here, this panel, REC panel, which has a 3 bypass diodes. Okay, an IP67 rating is the panel that we can use in the external environment. So all these things will be available in the data sheets. And also cell type also you can know. It is a 72 multi-crystalline cells, and we have a 3 strings of 24 cells in series. Okay. And also, as I told earlier, what will be the minimum glass thickness should be 3.5 to 4. See here, the glass thickness is 4 mm. Okay. So back sheet is also there. Okay, we have a anodized aluminum frame. Okay. Connector details also provided, which is of 4 mm square cable is used. Okay, so all these things you can find in the data sheets. So it will have a little more clarity on the things that we had discussed. So that's why I had opened this data sheet and explained it to you. Okay, and also if you want to know the inverter details, okay, you try to get any inverter. So now let us have an example of a solar inverter. Okay, see here, so there are so many models, 3 kilowatt, 4 kilowatt, 5 kilowatt, 6 kilowatt, 7 kilowatt, 8 kilowatt, 9 kilowatt, 10 kilowatt, like this. So many models are there. So you know, each and every model you can have a rated AC power volt you can see, and what is the maximum DC power you can give, that is 4050. Okay, watts. And also most important thing that we want to know is what is the maximum output current per phase we can get, that is 5 kilowatt, 5 amps you can get. Okay, Apart from it, some more additional details that if you want to know what will be the maximum input current that you can give to a particular inverter, all these details is 5 amps, like the 7 amps, based on the different type of inverters. We have the ratings will be different, but all these things you can find in a data sheet. So if you want to do any sort of calculation, have a data sheet with you. So as we explained the different formulas here, take a data sheet of the battery, inverter and the solar panel that you are going to plan, and you need to know the load capacity, that is AC and DC loads. Collect all this information, and with the help of these formulas, try to find one by one. We have provided all the details, so it will be easy for you to calculate. Okay, so thank you so much. So if you want to know more and learn more, feel free to contact us, and we have provided the contact details. We are providing the training supports also. You can contact us. If you need any consultancy supports or a training supports, you can contact us. So we have provided contact details. We are providing the electric vehicle basic trainings also, and we are also providing solar basics trainings also for the on-grid, off-grid and hybrid application. And also we are providing industrial automation, building automation. Okay, what how automation we can use in the metro stations. Okay, all the basics we are providing, so you can contact us. Thank you so much.